131 tons, 1,650 tons, and a quarry that still holds the largest cut stone on Earth, not because the builders forgot it, because something stopped. At 3,850 meters above sea level, in the Bolivian Altiplano near Lake Titicaca, there is a site called Pumapunku. It is not a pyramid. It is not a temple in any traditional sense. It is a field of broken stone, and the stone itself is the problem. The blocks here are not simply large, they are machined. Red sandstone surfaces show straight edges, H-shaped interlocking cuts, repeated drill holes and T-shaped grooves that match corresponding forms on adjacent blocks. Jean-Pierre Protzen and Stella Nair, who studied the site in detail, documented evidence of pre-planning, interchangeable components, and joint tolerances in the range of 1 to 2 millimeters across stone that had no business being this precise in 600 CE. The largest red sandstone block weighs approximately 131 tons. Petrochemical analysis places its origin roughly 10 kilometers away. The andesite blocks traveled farther. Their source is traced to the Copacabana Peninsula, nearly 90 kilometers across Lake Titicaca. The official explanation offers a working principle: ropes, inclined planes, organized labor. What it does not offer is the full operational model: friction coefficients, descent control, how finished faces survived transit, how identical forms were reproduced without industrial tooling. The answer describes what was possible. It does not reconstruct what happened. Now move west. Lebanon, the Bekaa Valley, Baalbek. Here the question is not precision, it is mass. The Temple of Jupiter sits on a podium built partly from 3 limestone blocks known as the Trelathon. Each runs approximately 19 meters in length and weighs between 750 and 800 tons. They are fitted into the podium with visible care, edges intact, joints closed, horizontal alignment maintained across a span that no modern heavy transport would take lightly. In the quarry 900 meters away, the situation becomes stranger. In 2014, a team from the German Archaeological Institute working with Janine Abdul-Masih documented a monolith still lying in the rock face. Its dimensions approximately 19.6 by 6 by 5.5 meters. Its estimated weight around 1,650 tons. It was never moved. The quarry is close. That is what makes this harder, not easier. Proximity solves the geography. It does not solve the engineering cycle: separation from bedrock, stabilization, horizontal movement across uneven ground, approach to the podium, alignment and final seating, all for a load that exceeds the rated capacity of any single crane operating today. The undelivered stone is not a failure, it is a data point. It marks the upper limit of what was attempted, or the exact moment the operation stopped. 2 sites, 1 pattern. The official version names the builders. It describes the tools in general terms. What it does not do is close the gap between the explanation and the object. 131 tons on a high plateau, 1,650 tons in an open quarry. The stones are still there. The mechanism is not. At Baalbek, the problem was a stone that didn't move. Here, the problem is a wall that shouldn't hold, and a city that shouldn't breathe. Above Cusco at 3,701 meters, there is a structure the Spanish chroniclers described with visible discomfort. They had seen Roman walls and Moorish fortifications. Sacsayhuaman was something else. 3 massive terrace walls, the longest running approximately 400 meters, built from limestone blocks fitted together without mortar. The largest single block is estimated between 128 and 200 tons. Between many of them, a sheet of paper does not pass. That detail sounds like a demonstration of craft. It is actually a structural decision. The irregular interlocking geometry of Sacsayhuaman's stones, no 2 faces identical, each block shaped to its neighbors, produces a wall that moves under seismic stress rather than shattering. The joints absorb the displacement. Cusco sits in a seismically active zone. The wall has outlasted the Spanish colonial buildings constructed directly beside it. Several of those buildings have needed reconstruction. The Inca stonework has not. The question is not whether ancient Andean builders were capable of this logic. They clearly were. The question is operational. Each stone required either precise pre-modeling or repeated trial fitting. For a 100-ton block, a single incorrect face means lifting it again, moving it, correcting the surface, returning it. There is no record of how many correction cycles each stone went through. There is also no crane. What exists is the result, and the result works. In 2025, researchers using ground-penetrating radar and acoustic probing reported evidence of a passage running between Coricancha, the Inca temple at the center of Cusco, and Sacsayhuaman, approximately 1 mile in length, roughly 8.5 feet wide and just over 5 feet tall. If confirmed, the wall above is not a wall. It is the surface of a larger system. Now go underground entirely. Cappadocia, Central Turkey. The site is called Derinkuyu. It extends approximately 85 meters below the surface across multiple levels, with a ventilation shaft running roughly 55 meters and documented spaces including stables, cellars, a missionary school, a church, and a kitchen. Turkish museum records note that some wells were deliberately not connected to the surface. A design choice, not an oversight. During a siege, an open well is a poisoning vector. The builders knew this. The volcanic tuff of Cappadocia is soft enough to carve by hand. That explains how the rooms were cut. It does not explain how the system was planned. Thousands of people, animals, fires, and oil lamps sharing enclosed space consume oxygen and produce CO2 at rates that are straightforward to calculate. An unventilated underground room becomes dangerous within hours. Derinkuyu was designed to hold populations for extended periods. That means someone modeled, or arrived at through long experience, the airflow requirements across multiple levels, the separation of smoke-producing areas from sleeping areas, the pressure differential needed to move air passively through a shaft 55 meters tall. None of this required modern engineering, but all of it required a system. A system has logic. Logic has to come from somewhere. Sacsayhuaman shows stone fitted to stone with seismic precision. Derinkuyu shows air fitted to human survival at 85 meters depth. In both cases, the object works. In both cases, the full process that produced it remains at the level of mechanism incomplete. One structure predates civilization as the textbooks define it. The other outlasted every material science assumption made about it for nearly 2,000 years. The standard sequence runs like this. Hunter-gatherers survive. Surplus agriculture develops. Settlements form. Social hierarchy emerges. Then eventually monumental architecture becomes possible. The institutions produce the monuments. Göbekli Tepe breaks this in the first term. The site sits in the hills of southeastern Turkey, in what was Upper Mesopotamia. Its oldest layers have been dated to approximately 11,500 years ago. Pre-ceramic, pre-agricultural, before any of the institutional infrastructure the sequence says is required. The people who built it were hunter-gatherers. What they left behind are T-shaped limestone pillars up to 5.5 meters tall, carved with animal reliefs, arranged in circular enclosures with the largest reaching roughly 20 meters in diameter. In 2020, Gil Hockley and Avi Gopher published an architectural analysis in the Cambridge Archaeological Journal showing that 3 of the major enclosures, B, C, and D, share a geometric relationship consistent with unified prior planning. Using a computational algorithm to trace structural axes and center points, they found a triangular arrangement that suggests the complex was not built incrementally by separate groups over separate generations, but was conceived, at least in outline, as a single project. This is the part that resists easy framing. It is not that hunter-gatherers lacked intelligence. It is that the old model assumed intelligence alone was insufficient, that you also needed surplus hierarchy and written coordination to produce this kind of spatial abstraction at scale. Göbekli Tepe does not disprove the model quietly. It simply exists, 11,500 years old, geometrically planned in a layer of history where the model says it should not be. Official archaeology has accepted the site. The implications have moved more slowly. Now Rome, 125 CE. The Pantheon is complete. Its dome spans approximately 43 meters in diameter and remains the largest unreinforced concrete dome of its kind still standing. Britannica notes directly that the exact method of its construction has not been fully established. That sentence is doing significant work. It appears in a reference source describing a building nearly 2 millennia old that anyone can visit this afternoon. For most of that time, the assumption was that Roman concrete was simply a good recipe, well executed. Then material scientists started looking at the microstructure. A 2017 study associated with Marie Jackson at the University of Utah examined Roman marine concrete and found that seawater interaction with volcanic ash and lime had produced crystalline mineral phases, including a luminous tobermorite, that actually strengthened the material over time. A 2023 paper in Science Advances identified a separate mechanism. White lime clasts embedded in the concrete, previously read as signs of poor mixing, appear to participate in crack self-healing by reacting with water that infiltrates the structure. The Pantheon did not survive because Roman engineers got lucky with local materials. It survived because the material they produced behaves differently from modern concrete under long-term stress, and that difference is now being studied as a design principle for future construction. One building proves that monumental planning preceded the institutions supposedly required to produce it. The other proves that a material mixed 2,000 years ago contains chemistry that contemporary engineering is only now learning to replicate. In both cases, the uncomfortable detail is not the age. It is what the age implies about the sequence. This one is different. It was built in the 20th century. The builder had a name, an address, a death certificate, and the mechanism is still not fully on record. Edward Leedskalnin arrived in Florida in the early 1920s. He was Latvian by birth, slight in frame, approximately 120 pounds, and had no construction background on paper. Between 1923 and 1951, he quarried, shaped, transported, and positioned more than 1,000 tons of oolitic limestone, working predominantly at night, predominantly alone. The result stands in Homestead, Florida, and is documented by Britannica as a complex of massive stone sculptures created by a single individual using basic but effective tools. That description is accurate. It is also the entire extent of the official account. The site attracted legends quickly. Leedskalnin was private about his methods. He was seen with tools, a tripod, chain hoists, pulleys, but rarely while working. Visitors who arrived unannounced found him waiting, the stone already moved, the mechanism already packed away. This is not evidence of the supernatural. It is evidence of a man who understood that the most reliable way to protect a process is to never demonstrate it in public. The 9-ton gate became the signature claim. For decades, it could be moved with a single finger, a fact that generated the full range of theories from magnetic current to geometric secrets borrowed from pyramid builders. The actual explanation, identified when the gate was examined after it stopped moving smoothly in the 1980s, was a steel shaft running through the center of mass, seated on a truck bearing. The gate was balanced precisely at its gravitational midpoint. When the bearing wore out, the ease of movement disappeared with it. This is the only part of the story where the mechanism is fully recovered, and it does not diminish the problem. It sharpens it. Leedskalnin located the center of mass of a 9-ton irregular stone block, drilled a shaft hole accurate enough to function as a mechanical bearing axis for decades, and seated the assembly without visible equipment or assistance. The explanation for how the gate moved is complete. The explanation for how it was built to those tolerances by one person without a machining facility is not. The wider inventory compounds this. Over 1,000 tons of material, each block quarried from the ground with hand tools, separated, lifted, repositioned, and in many cases placed with enough accuracy to function as furniture. A rocking chair, a sundial, a telescope aimed at Polaris. Oolitic limestone is porous and lighter than it appears, which helps at the margins. It does not help enough to make the production cycle legible. Levers, tripods, and mechanical advantage explain the principle of each individual lift. They do not account for the sequencing. How one person manages a suspended load while repositioning the base point alone at night without a safety system. There are no photographs of the process. There is no written record of the method. Leedskalnin died in 1951 and left behind the structure and a short self-published pamphlet on magnetic current that has never been connected to any verified physical principle. Coral Castle is not evidence of lost technology. It is evidence of something quieter and harder to resolve, that a complete operational record can disappear even in the 20th century, even in Florida, even when the object is still standing in front of you. If the protocol vanishes here, it is worth asking what vanished everywhere else. Everyone knows Stonehenge. That familiarity is the problem. It has been looked at so long that the actual question stopped being asked. The question is not what Stonehenge is. The question is what it cost to build it, and who decided that cost was worth paying. The monument on Salisbury Plain is two things at once. The sarsen stones, averaging around 25 tons each, came from Marlborough Downs, roughly 25 kilometers north, heavy but local by megalithic standards. The blue stones are different. They weigh between 2 and 5 tons individually, modest by comparison. But their origin is the Preseli Hills in southwestern Wales. English Heritage places the quarry sources at nearly 180 miles from the site. A team from UCL, Southampton, Bournemouth, and the National Museum of Wales identified 2 specific extraction points. Carn Godog for spotted dolerite and Craig Rossi Phelan for a type of rhyolite. Both sites show quarrying evidence dated to approximately 3000 BCE. For a long time, there was a way around the transport problem. The glacier hypothesis proposed that Pleistocene ice had carried the blue stones, or material close to them nearer to Salisbury Plain as natural erratics, deposited by retreating ice, then collected and used by Neolithic builders who found them nearby. It was a reasonable hypothesis. It removed the hardest section of the route. In 2026, a study by Clark and Kirkland published in Communications, Earth and Environment used UPB isotope fingerprinting of zircon and apatite grains from river sediments around Stonehenge to test this directly. Their conclusion: Salisbury Plain was most likely unglaciated during the Pleistocene. Direct glacial transport of the megaliths to that location is improbable. What remains when the glacier is removed is people and distance. In 2021, Mike Parker Pearson's team published findings on Wan Mon, a dismantled stone circle in the Preseli Hills in antiquity. Radiocarbon and OSL dating placed its construction around 3000 BCE. The circle shares a diameter consistent with the bluestone arrangement at Stonehenge, and at least one stone socket matches a bluestone currently standing on Salisbury Plain. The hypothesis, contested but in active research, is that Wan Mon was partially dismantled and relocated. Not stone as building material. Stone as a place moved intact to a new location. If that holds, the transport problem changes character entirely. The question is no longer why someone moved 2 to 5 ton stones across 180 miles. It is why a community decided that a specific circle of stones from a specific place needed to exist somewhere else, and then organized the generational labor to make that happen. The official account offers sledges, timber rollers, ropes, water routes for sections of the journey, and the collective capacity of Neolithic society. These are probably all correct as components. What they do not assemble into is a complete operational model. The friction load per kilometer, the crossing points, the seasons, the number of people required per stone per day of movement, the food supply for that labor force, the coordination across a landscape without fixed communication. 10 structures, 10 versions of the same gap. The dates are known, the cultures are named, the stones are measurable. What remains open, at Pumapunku, at Baalbek, at Sacsayhuaman here, is the space between the result and the process that produced it. That space is not filled by the word impossible. It is not filled by the word obvious either. It stays open. And structures that stay open this long are usually telling you something the summary forgot to include.